Welcome to SYDE 522 Machine Intelligence. I don't want to go over all items in the course syllabus, just the important topics that I will briefly mention here. So please, as all communications will be through Learn, just take a look. Start with there. Right now there's nothing there, just the course syllabus. Take a look at it, all the details. I'm sure you know the class times and tutorial times and everything else. Before we jump into the material, I want to go over the most important parts of the syllabus, and maybe we have a little bit of discussion before we start with the material. And I want to start with material today because we have to cover a lot, and in order to do that, we cannot waste time. So, the objectives of the course, I hope you see, because one of my problems with this classroom is that it was not traditional boards, and I have difficulty to write with the markers, so hopefully we will be doing okay. So objectives of the course. So we want to learn basic concepts of AI, and we will clarify what we mean with AI when we start soon. So we want to see what are the basic concepts, not just one or two methods that I can look, I don't know, at some YouTube videos and say, okay, method X works like this. But the basic concept, what are they? We want to learn anything that I write here, we want to learn. So this is the objective. Learn different methods for function approximation. So why function approximation? Because as we will hopefully see and discover together, machine learning, AI, computational learning is nothing but function approximation. We approximate functions that are not known. Nobody knows the equation for those functions. So we approximate that. That's the fundamental difference between AI and classical math. So we want to learn some of them. So we want to learn how to select the correct or the right learning scheme. So if a problem is given, how do I know which method from the AI repository can I select to solve that problem? This is one of the fundamental skills in AI that you cannot acquire in a short time. There's no way around it. There is no online course, there is no certificate, there is no YouTube video, there is no blog that can prepare you to do this in 2 months or 4 months. After 10 years, you will be there. So, and that can save time. That can save development time. So that can save time of design. So of course, we want to see and learn what is the difference between shallow and deep learning. Although deep learning for us is, I don't know, is maybe 20% of what we do in this course, but since at the moment is one of the most successful AI technologies, we have to talk about it. We will talk about it. We will go in details of one or two of those methods. And we want to see what we just say, what is the difference between shallow and deep? Should we dismiss now all shallow techniques that we have, or we still keep the shallow techniques? That's very important for us to figure out in this course. There is no way that we can solve all problems just with deep techniques. There is no way we can do that for many, many reasons, as we will hopefully find out together. So how do we verify the learning capability of different techniques? As a matter of fact, we will start today with a historic example in this regard. If a technique says I can learn, how do I verify that it has learned? How do I know? Who is in charge? Who will tell me, yes, this technique has learned, and now you can use it and you can rely on it? Because when I deploy it after some sort of training, then people will trust that it has learned. Now it will deploy its knowledge in some way.